You hear it every morning when you step outside onto your porch, a sharp, rhythmic sound that seems like background noise. But discovering the true Chickadee alarm call meaning changes how you listen to your yard. The small black-capped visitor on your feeder is not just making noise. It is broadcasting a complex, real-time data stream to the entire neighborhood. While you pour your morning coffee, this tiny creature is assessing the world with a level of precision that rivals military radar. It sees the shadow moving through the maples long before you do. It measures the danger in centimeters and seconds. Within a single utterance, it packs a wealth of multi-layered information that shapes the behavior of every living thing within earshot. A hidden language is operating right outside your window, waiting to be deciphered. Most of us look at small garden birds and see simple, reactive creatures. You might assume a bird sees a threat, feels fear, and screams blindly to warn its mate. It feels like a primitive binary response to the world. Safe or unsafe, on or off. We tend to believe that complex linguistic coding belongs exclusively to humans, or perhaps a few mammalian cousins. But this view of the natural world is incomplete. The chickadee does not panic, it analyzes. When a predator enters the airspace around your property, the response from the feeder is not a chaotic cry for help. It is a calculated, structured report. The bird is executing a cognitive feat that science is only beginning to unravel, challenging everything we thought we knew about animal communication. To understand this hidden system, we must look at a landmark study from the University of Washington, published by Dr. Christopher Templeton in 2005. His research team isolated chickadees and exposed them to 15 different species of raptors. They discovered that the classic note we all recognize is far more than a simple warning. The familiar sound is constructed from 4 distinct acoustic units labeled A, B, C, and D. The birds mix, match, and repeat these notes in specific variations. They do not just say that a predator is present. They encode the exact size of the threat, its speed, its proximity, and its intent simultaneously within a single vocal string. Consider the scale of this achievement for a brain that weighs less than a single gram. When a massive red-tailed hawk glides over your roof, the chickadees barely alter their melody. You might hear a brief, standard call. This seems counterintuitive to the human observer. We expect a giant hawk to cause the greatest panic. But to a chickadee, a heavy, slow-moving hawk is a minor concern. It cannot maneuver through the dense brush of your garden. The true terror is a small, agile saw-whet owl or a sharp-shinned hawk. When these compact, lethal hunters appear, the structure of the call changes instantly. The acoustic profile shifts, alerting the entire forest to a high-priority emergency. The mechanics of this encoding rely heavily on the final note of their call. The specific number of repetitions carries the heaviest weight of data. A normal, relaxed call might feature 2 trailing notes. But when Dr. Templeton introduced a highly dangerous pygmy owl, the chickadees added up to 20 extra notes to the end of their phrase. The duration and variation of these sounds map directly to the wingspan and hunting strategy of the intruder. How do the other creatures in your yard react to this dense stream of data? The answer reveals a massive, interconnected network of neighborhood surveillance. You might think this information is a private channel kept strictly between chickadees, but it is actually a public broadcast. A study from the University of Montana in 2007 demonstrated that nuthatches, tufted titmice, and even migrating warblers actively eavesdrop on these calls. They decode the specific threat matrix embedded in the sound. If the chickadee signals a slow hawk, the neighborhood continues feeding. If the chickadee signals a fast, small owl, the entire canopy goes dead silent. The nuthatches will even alter their own foraging posture based entirely on the number of notes they hear from the branch above your feeder. This cooperative surveillance network reframes our understanding of evolutionary intelligence. The chickadee acts as an unintentional sentinel for the entire ecosystem. This reveals a profound truth about the natural world outside your door. Intelligence is not always housed in large, solitary minds. It is distributed across a web of interconnected species who share a common language of survival. A study published in the journal Behavioral Ecology in 2015 showed that even red-breasted nuthatches alter their own alarm calls to mimic the urgency of the chickadee's warning. The boundaries between different species blur when survival depends on collective information. The small bird at your window is a node in a living Internet of Things, constantly pinging the environment with updates. Let us return to your yard tomorrow morning. You stand on the porch, coffee in hand, listening to the familiar melody. But now, you do not just hear a bird singing. You hear a complex data transmission. You notice the subtle variations in the syllables. You look for the extra notes trailing at the end of the phrase. You realize that if a small cat is stalking through the grass under the porch, the chickadees are already broadcasting its exact position, speed, and intent to every creature in the neighborhood. The space between your house and the trees is suddenly alive with geometry, measurement, and shared knowledge. The bird is no longer just a passive part of the landscape. It is an active interpreter of reality. Understanding this avian language fundamentally changes how we view our place in the natural world. Every time you fill your feeder, you are stepping into a highly sophisticated, communicative community. If you wish to look deeper into how these birds navigate and map the hidden spaces of your neighborhood, you should explore the complex ways they remember thousands of individual seed locations across winter. To see how these small minds handle memory and space on an even grander scale, click on the video appearing on your screen now, where we explore the incredible mental maps of backyard birds.